On September 11, 2025, the Solar Monitoring Satellite SH registered something impossible. An object so massive, so bright, it overloaded sensors designed to track the sun itself. Days later, Chinese telescopes confirmed it. Their colossal interstellar visitor, 100 times larger than 3I Atlas, had entered our solar system. Its size dwarfs cities. Its energy field outshines stars, and it moves not like a rock, but like a craft. What is SWAN? Where did it come from? And why now? For the third time in less than a decade, the universe has sent us something we can't explain. But this one changes everything. Arrival of the unknown. When the sun monitoring instrument swept past its usual steady heartbeat on the 11th of September, 2025 data scientists noticed something extraordinary. At that moment, the plasma flow detector aboard the spacecraft registered a spike in brightness thousands of times above its normal baseline, like a candle flame instantaneously turning into a searchlight. The object, now designated C25ER2 SWAN, had entered our solar system and shattered expectations. Its scale was staggering, roughly 100 times larger than the earlier interstellar visitor 3I Atlas, which itself had broken records in 2025. The detection moment came from what was meant to be routine: the solar wind monitor on board the observatory at the L1 gravitational balance point. This instrument, part of the broader solar monitoring infrastructure, tracks hydrogen atoms illuminated by sunlight, mapping the gentle glow of the sun's outflow. But on that September date, its readings exploded into something completely different. Instead of the usual steady hydrogen signature, the system detected an envelope of charged particles and electromagnetic activity far beyond any prior readings. It forced scientists to realize they were not simply observing a comet or asteroid, but something unlike anything catalogued. In the days following the spike, observatories around the world scrambled to observe SWAN's approach. The initial reports described a giant object moving inward from a direction nearly aligned with the plane of the ecliptic, arriving at an estimated distance of about 0.5 astronomical units, half the distance between Earth and the Sun at closest approach. Unlike typical natural objects, this visitor seemed to arrive with purpose. It disrupted our assumptions about what might wander into our solar neighborhood. The notion that this could be a fragment of some forgotten cosmic event, or even a pattern in progress, became unavoidable. The realization sank in: our solar system, long thought to be well monitored, had allowed a visitor of truly massive scale to enter almost undetected. If its size was indeed 100 times that of 3I Atlas, which itself measured perhaps a few kilometers across, then SWAN's dimensions could extend tens or even hundreds of kilometers. That scale invokes not just a natural anomaly, but a fundamental question. Are we witnessing the arrival of something biologically or technologically driven? The universe was delivering a moment of cosmic humility, reminding us that our place in it might still be far less certain than we assumed. As the shock of the detection began to settle, the spotlight turned toward the ground-based facilities, especially those in China that first captured this visitor. Their telescopes, scanning parts of the sky often overlooked by Western surveys, picked up critical early data on SWAN's trajectory, composition, and behavior. The first Earth-based confirmation of SWAN came from an unexpected corner of the planet, Yunnan Observatory, operated by the Chinese Academy of Sciences, on the night of September 12, 2025. Just one day after SOHO's initial anomaly, researchers using wide-field optical telescopes picked up an extremely bright object moving against the starfield. The object's unusual speed, angle, and reflectivity caught the attention of lead astronomer Dr. Li Wei, who immediately flagged the data for further review. This was not a routine comet. It was something altogether unprecedented. Within 36 hours, China's premier radio telescope, the 500-meter Aperture Spherical Telescope, FAST, turned its dish toward the object. The readings were off the charts. Instead of the weak, noisy signals typical of icy interstellar debris, FAST detected strong, modulated radio emissions, some of which repeated at intervals close to 12.2 seconds. These pulses suggested not only electromagnetic activity, but possible control systems. SWAN, it appeared, was not simply reflecting sunlight. It was actively interacting with the solar environment in ways never observed. Its spectral signature indicated a high presence of refined nickel and cobalt rather than the usual carbon-rich or icy materials. What made China's early detection so critical was the object's solar masking approach. SWAN entered from a vector just 2.1 degrees underground and off the sun's ecliptic glare, an angle that makes observation incredibly difficult for telescopes in the Western Hemisphere. Most near-Earth object detection systems are designed to avoid looking too close to the sun to protect sensitive optics. But due to seasonal orbital geometry and its own geographic latitude, the Yunnan facility happened to have a clear line of sight during a narrow 90-minute observation window. That stroke of luck provided the world its first high-resolution images of SWAN. In the hours that followed, China's National Space Science Center issued a shared alert through the International Astronomical Union. The alert included precise coordinates, magnitude data, and preliminary velocity estimates, pegging SWAN's inbound speed at 52,000 km/h, slower than Oumuamua, but far more massive. The international community quickly pivoted. Observatories from Japan to Chile adjusted their tracking software to accommodate SWAN's rapid transit. What began as a regional anomaly transformed into a full-blown global watch. The role Chinese observatories played in this critical first window cannot be overstated. With SWAN now confirmed, observed and catalogued, attention turned to its structure, what it was made of and how it moved. Observations from both Earth and orbit revealed an object that defied classification. It didn't behave like a comet, asteroid, or even a rogue planet. At the heart of SWAN's mystery lies its structure, one unlike anything previously catalogued. Traditional comets exhibit chaotic plumes, uneven tails, and surface shedding driven by solar heat. SWAN, by contrast, maintained a perfectly symmetrical plasma envelope that spanned 2.5 degrees of sky, or more than 5 full moons side by side. Even amateur astronomers from rural parts of Sichuan province reported visual sightings using basic gear. This glow wasn't just bright. It was controlled. The plasma shell held uniform density across its entire arc, indicating a stabilized electromagnetic field. Laboratory spectroscopy performed on light reflected from SWAN identified the presence of highly refined nickel, iron, and cobalt, materials more commonly associated with industrial metallurgy than with naturally formed comets. The metals showed low oxygen contamination and lacked silicate compounds, suggesting they hadn't been forged in typical stellar debris environments. More strikingly, the reflectivity suggested surface refinement, as if the object had been polished. No known celestial body exhibits such precision in material composition unless processed. But perhaps the most confounding element was SWAN's navigation. As it moved closer to the sun, approaching 0.5 astronomical units, the object began making minor path corrections. These adjustments occurred at moments of gravitational inflection, particularly when passing near the orbital path of Venus on September 19th. These weren't the random pushes caused by cometary outgassing. They were precise timed shifts that indicated real-time responsiveness. Imagine watching a 10 billion-ton object steer itself like a drone correcting for turbulence, except in space. And at over 50,000 km/h, even SWAN's tail, or what should have been a tail, didn't behave normally. Instead of a trailing stream of dust and ice, the object emitted a magnetically constrained ion trail aligned perpendicular to the solar wind. This effect, theorized only in magnetohydrodynamics models, had never been witnessed on a macro scale. The tail's orientation and stability implied active magnetic field generation, likely powered by internal systems of vast complexity. This raised the fundamental question: was SWAN a natural formation or a vessel?